Kate Abbott, and today I'm sharing a summary of our recent freshwater biomonitoring work on the Deerfield River. Freshwater biomonitoring uses aquatic biological communities to assess the overall health of a river ecosystem. So instead of a snapshot in time, it really integrates conditions over a period of weeks to months. Now we focus on benthic macroinvertebrates because they're really diverse, span a wide range of tolerances to pollution, habitat, and disturbances. They respond to multiple stressors and are relatively easy and inexpensive to sample. So together they can provide a snapshot of overall river health and conditions. The Deerfield River is a heavily regulated system with 9 dams, and these dams alter natural flow patterns, habitat structure, and water temperature. Because all these changes act together, biomonitoring can be especially useful because it captures the cumulative effects of regulation rather than just isolating one stressor alone. Now, Cole Ecological and others have conducted biomonitoring assessments on the Deerfield River in previous years. A regulated flow effects study was completed in 2006, followed by a more comprehensive ecological assessment in 2013, covering 11 sites and spanning 35 river miles. Mass DEP has also conducted periodic sampling at a handful of sites across the watershed and the main stem river. Since 2013, though, there has been no significant biological monitoring on the Deerfield beyond those limited DEP data. But at the same time, a major change is coming thanks to the FERC relicensing of the Fife Brook Dam and Bear Swamp project, which resulted in an increase in winter minimum flows from 125 to 225 CFS expected beginning in 2028. So to understand the ecological effects of that change, we need a current biological baseline. And with nearly 20 years of historical data available, this is a really important opportunity to better understand existing conditions in the river, as well as how these conditions might change as a result of operational changes of the Fife Brook Dam. So to reintroduce this project to the chapter and hopefully generate some interest in adding to this data set, we completed a pilot study in September 2025, thanks to some wonderful volunteer support. We sampled 3 sites between Fife Brook Dam and Number 4 Station at river miles 37, 34.5, and 25. And while limited in scope, this pilot did provide some valuable insight and also confirmed the feasibility of broader monitoring. We observed some clear patterns emerging across sites. These figures generally show relative abundance and number of taxa on the y-axis and site on the x-axis. So closer to Fife Brook Dam, we observed higher abundance and richness of chironomids or midges. In contrast, mayfly abundance and richness were reduced near the dam and increased as we went downstream, which is a signal often associated with altered flow and temperature regimes. So overall macroinvertebrate densities were lower closest to the dam. Caddisfly densities were relatively similar across sites. Stoneflies were consistently low in abundance across sites. And together these results suggest a spatial gradient and community composition related to the distance from the dam. When we compare these results to earlier work, the pattern holds. Overall richness values are similar between 2013 and 2025. And the community composition gradient between Fife Brook Dam and Charlemont remains strong. So this suggests a persistent biological response to long-term flow and thermal alteration rather than short-term variability. So in summary, we do see a consistent gradient in macroinvertebrate communities downstream of Fife Brook Dam. Reduced mayfly abundance and increased chironomid dominance persist over time, likely linked to altered hydrology and temperature. Though there are some important caveats I'd like to mention. So for this pilot study, we only collected 1 sample at each site, and the spatial scope was limited to 3 sites. So for future efforts, increased replication at each site, like duplicates or triplicates, as well as a broader spatial scope would be helpful in assessing overall river conditions. So looking ahead, the next steps are to collaborate with the TU Deerfield chapter to plan and implement a benchmark assessment similar to that conducted in 2013 before the new flows are implemented in 2028. So this work would build on the existing data sets and contribute to our overall understanding of river health and allow us to understand how management decisions, hydro operations, and climatic trends can shape the Deerfield River ecosystem over time.